All right, I'm gonna keep run, and I'm going to invite everyone here. Okay, and I'm going to stop
Oh, just a
the.
heads up. Is it okay that I'm showing this on my screen or on my stream?
Yeah, yes, of course, of course. Mhm.
Okay, I don't know if like students didn't want to have their names on screen or whatever.
I'm gonna make a disclaimer about that. They won't have their names on the YouTube stream on my end.
Okay, because
Yeah.
okay, then I probably shouldn't have that on my stream either, right?
I don't think it's a big deal, but up to you. Yeah.
Okay.
Okay.
All right.
So let me then I think we can probably get started. So, and we are on YouTube as well. Yes, we are connected on YouTube. All right, beautiful. Okay. Good morning, everyone, or good afternoon, good evening, wherever this might find you. And welcome to the third guest lecture here at the Introduction to Computational Design course at the Harvard Graduate School of Design. It is with great pleasure that I'm welcoming Freya Holmér to be the last guest speaker of our class. I've been a huge fan of her work and her outreach for many years now. And I'm very happy that she invited our invitation to be here. Hi, Freya. How are you doing?
Hello. I'm doing good. A
All right.
little burnt out, as you know. So, but hopefully this will go okay.
I think this is going to be great, and hopefully it helps you like maybe get back into the wheels of like doing these things. I don't know, or not. I don't know.
Yeah, we'll
So
see.
we'll see. So I would like to run through some logistics before we start. So I want to remind everyone that the people who are right now on the Zoom call are part of the class community and from the university community. But I also want to remind everyone that this lecture is being live streamed to YouTube right now. So if you don't want your face to show up on the live stream on YouTube, please turn on your webcam. And also what I would like to remind everyone is that the way we're going to conduct this is that it's going to be perhaps less of a traditional lecture, if you will, and it's going to be perhaps more of an interactive Q&A model. We were very excited about the idea of like maybe instead of like a formal, like this is content, this is work, blah, 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 we could make it more interactive and we could make it more about basically, whatever questions people in the audience may have related to the idea of creativity, related to the idea of mathematics and the idea of how they interplay together. And Freya was actually very excited about bringing this model as an innovation to the way we conduct this lecture. So what we're going to do is she's going to do a very brief intro perhaps to situate the conversation, but we will very rapidly transition into Q&A. So I will open it up to questions from people here in the call, if you want to just offer questions to Freya, and then she can address them in real time. And also to people who might be connected in the YouTube live stream right now, which I see a lot of them. I see the chat is exploding. So what I will also do is that I will pick up questions from the audience in the YouTube live stream chat, and I will relay them to Freya at regular intervals. Okay. Does that sound like a plan to everyone?
Yeah.
All right.
Well, I mean,
beautiful.
I guess I agreed to it beforehand.
Yes. Yeah, I haven't written. So I'm going to do a little bit of an intro to Freya. And Freya, please correct me if anything that I say is wrong, because I put this together by shamelessly stalking you over your social media and blog posts and what I could find about
That's
your
great.
life
I'm a very
on the
public
internet.
person, so it's intentionally put out there.
Yes. So I would like to welcome Freya here to the talk. She is a game developer and a technical artist whose work mainly revolves around visually exploring the formal beauty of mathematics with video games and with education as her main medium of expression, if you will. She studied game design at the Future Games School in Stockholm, where she learned more about game development, programming, 3D modeling, and art in general. She has worked as developer and technical artist in multiple game development projects, including Budget Cuts 1 and 2, and I believe you were co-founder of the company that developed those two games, correct? And I believe you work also in Roman and Nuts. I'm not pronouncing it. Roman.
Yeah,
Not,
yeah, there were
not,
2 freelance projects. I was doing freelance tech art for those 2.
Freya's contribution to the community includes amazing tools such as, for example, Shapes, which is a shader-based vector graphics library. And funny enough, this is how I started learning about her work. And then Shader Forge, which is a node-based shader editor with Unity, a very similar interaction model as Grasshopper. And I believe it's now basically the de facto standard in industry for shader modeling.
It used to be, yeah. I think there are other ones that are taking over since I abandoned it and made it open source, basically. But for a long time, it was the standard within Unity development.
I wonder if we can hear a bit more about that story in your presentation. And then she's also done an extension to the floating math library in Unity, multiple visualizations and explanations of mathematical concepts via her Twitter and her website. I really, really recommend you check this out. They're mind-blowing. And multiple tutorial series on her popular YouTube and Twitch channels, which we are actually, I believe we're actually right now streaming the back end of this lecture on her YouTube, on her Twitch account. Freya is currently a freelance artist and live stream celebrity based in Stockholm. And I believe she's also the proud mother of toast, pork, and salad. Is that correct?
Yes.
Yes.
My cats. They're great. I love them. They might disrupt this entire lecture, but I consider it a feature, not a bug. So
that's a very beautiful way of putting it. So without further ado, please join me in welcoming Freya today.
Oh yeah, thank you so much for having me. This is mostly going to be a very improv short thing, so I hope you have questions at the end. I've been dealing with burnout as of late, so I haven't had time to make a super proper formal presentation. But I figured I could give you a bit of an overview of who I am and what I do and how I reason around all of the things I do, basically. So I've been in the games industry for about 12 years. I've been at both a big studio and then smaller studios. And I kind of quickly find myself more comfortable working in smaller studios because bigger studios tend to narrow you down to one specific field. And I'm more of a indie developer. And what that means that I like working in smaller teams and I enjoy going across the different disciplines that are within game development, for better or for worse. And yeah, we mentioned a little bit about, I've been working in the Unity tech art sphere for quite a long time. So I guess a lot of the things I wanted to bring up, I guess you already covered, so I'll just skip those. Yeah, and so I think we should probably share my screen. Screen 2 is blacked out. I don't know if I can actually share my screen. Is that going to work?
It's looking great. Yes.
Okay, cool. Neat. Yeah, like I mentioned, I worked on a project called Budget Cuts. So that was a VR stealth game quite early on for the Vive. So that's Budget Cuts. It was a very fascinating project to work on. I did a lot of tool development. I did a lot of shaders and some level design and that kind of stuff on it. Worked on the portals in that game, which was a very interesting technical challenge of, you have this hardware that has 2 cameras instead of 1, and you need to render both of them, and then also creating this kind of portal effect, which effectively is another set of cameras for that portal. So it was quite a challenging, interesting experience. But yeah, so those Budget Cuts, I did that at Necorp. And again, I kind of go cross-discipline quite a lot. So sometimes I do VFX and shaders and 3D modeling, that kind of stuff whenever it's necessary for the project. Because again, I really, really enjoy almost every single aspect of game development I enjoy doing, all the way from programming to 3D art and game design and level design. And I've been sort of, ever since I started doing game development professionally, I've been sort of getting pulled into talking about math. And I think I got initially interested in math because I noticed that how useful it was in game development. I think in a lot of cases, when you're learning about math in school, like growing up in high school or whatever, you tend to not have much of a context for math. It's kind of like, here are vectors, here's the dot product and the cross product, here's what a derivative is and how to calculate it. But nobody tells you why? Like, why should I learn this? Like, what's the point? Like, I know it's on the curriculum, but like, when am I ever going to need derivatives in my life? You know, a lot of people might ask that question. And so game development for me really became a like use case, a very strong use case for like a lot of different concepts within mathematics. And that was really inspiring to me because I've always felt like a lot of mathematical concepts are kind of beautiful in and of themselves, but there are a lot of people who never really see that beauty because they've only like looked at math from kind of the wrong perspective in my mind. And so I feel like one of the problems is that there's not always quite a lot of overlap between kind of the math and tech sphere and the art sphere and the design and user experience sphere. I feel like a lot of these people are sometimes pretty separated, where like someone who might be very excited about math might be a terrible artist. In fact, quite often, like math interested people are not very good artists and sometimes not even good designers. And the same thing goes for artists. Like a lot of artists are completely uninterested in math. It's just like, ugh, I don't know, those are just the boring numbers from school, right? Like that's kind of how you remember math if you're like more art interested. And the same thing goes for design. Like you might be super focused on like game design and level design, but you have almost no clue about art or even tech or programming. And so I think a lot of what I do is that I kind of want to place myself in the center, like very like selfishly, like put myself in the center. That's not to say that I'm like better than everyone and like, oh, I have all of them. Because like there's a lot of people who specialize in either of these and they're going to be better than me at all of those things. But I think there's something interesting with having a broad sense of these types of fields, because what that allows you to do is kind of create a bit of a bridge. Like you can bridge a lot of concepts from like take a math concept and explain that to an artist who might not be interested in math at all, but if you can design a way to communicate with an artist to communicate the concept of math or a specific concept in math that you find interesting, I think there is a lot of game development and game design you can just kind of factor into your educational approach. Because quite often it's like game design is all about like, what do my players already know? What do I want them to know? How do I make something visually appealing that they will get interested in? Like these are questions you ask yourself in game development all the time. And I think what I try to do is that I try to apply a lot of these concepts in my teaching as well. Because as soon as something is visual, you're going to get so many more people on board, like on almost any concept. And so for example, just to make this a little bit more practical, like let's say you present someone with this, like you just show them this, and you want to like, you're like super excited about this formula. You're like, this is so cool. Like this is like, I'm so excited about this. Have you seen the like Benstein polynomials for Bezier curves? It's so cool. Like there are so many artists who will like run away from you if they see this like nearby. They would just be like, oh God, that looks like a foreign language. I have no idea what's going on. Like what is happening, right? But one way to bridge that gap is to like pull it into a language that they are familiar with. Like as soon as you make something visual, like all of a sudden it's like, okay, so this is what those formulas are explaining, but we're just showing it visually instead of using the language of mathematics, right? And so I feel like this is one of those bridges you can build. Like if I want to explain Bezier curves, this is a much better way to get someone introduced who might not be that interested in math. And they're going to be like, okay, I can kind of see how you have this thing that's interpolating on a line, and we can sort of see that we're doing the same interpolation on these other lines. And all of a sudden you have a very visual guide for how these things work. And then you can work out the more like the mathematical details later. And that becomes more interesting once you have that visual first, right? You need to pull someone in before they're invested, right? And then if you want to draw more analogies for like artists, well, you can point out that the cubic Bezier curve, the one over here, the third one, like that one is the pen tool in Photoshop. The pen tool in Photoshop literally uses these curves in order to make the types of vector graphics you have. And so I feel like there's there's a lot of interesting approaches you can have to talking about math and art and design in ways that communicate better to whoever your audience happens to be. And so that's what I try to leverage in the work that I do. Let's see, just reading through my notes. Oh, I guess we can just ask questions at any moment. I don't have that much more of a intro spiel, but feel free to just think of questions and let me know if you have any.
If I may, anyone who may
Yes.
have a question on this call is welcome to interrupt at any point or raise their hand, and I will give you a cue. And people who might be on the YouTube stream, I'm also happy to relay questions in real time.
Okay, and so like I mentioned, a lot of my work involves technical art, and technical art is a very broad term, and it kind of encapsulates a lot of these different things. It's not just tech and art; it's also design and art as well, depending on which part of tech art you're in. And so tech art, for those of you who are unfamiliar in game development terms, it's usually someone who is working with the technical aspects of the visuals of your game, which usually involves shader programming, and someone who is often doing tools internally, like programming tools, and sometimes also designing those tools internally at game studios to kind of accelerate the work that everyone else is doing on the team. So you're kind of a bit of a glue that's like holding everything together, like working on bridging gaps between artists and programmers and designers and programmers as well. And so a lot of the work is shaders. And if you don't know what shaders are, it's basically code that is running on your GPU, your graphics card, that is purely defined in like this little code document that is full of just math functions. And what that does is that everything you see in a game is rendered, in other words, drawn using shaders. So everything visual in a game has mathematical function that tells you what color should this be, how should lighting be applied to it, how do we handle transparency, do we have refraction, kind of like the stuff you see here on this water surface. There's like a little bit of a white foam around the edges. There's refraction under the water. There's a very dramatic color change underneath the surface as well, and there's these little shiny glimmering lights on top of the water as well. And all of this is something you have to define explicitly in code or in a node-based editor when you're creating things like this. And sometimes I try to break down a little bit like how to do these things, because it can sometimes get a little bit messy when you're just looking at code. Oh, sorry, someone was talking?
I believe someone accidentally turned on their mic.
Oh, okay. Yeah, sorry, I don't want to miss any questions if you have any questions. And so if you, another example is this one. So this was a little rocket in a game that I've been working on. Never released it. I've just been working on it on and off for a long time. So here's this little rocket that's flying around, and it has this little flame underneath it, right? And you're accelerating and flying around and turning around, and you can see that the flame is actually changing quite a lot depending on what's going on. Like the time since you started accelerating or since you stopped accelerating, it reacts to the rocket turning left and right. You can see that it sort of does this little bend, right? And all of this is drawn in shaders, and it's just drawn on a single what's called a quad, which is two triangles effectively. And if I want to like communicate, like how do you make something like this? Sure, I can talk about the code, or I can just kind of make visualizations that can kind of showcase, all right, what are the different steps of making an effect like this? So in this case, we have this this noise texture that is scrolling vertically, right? This is just like straight up Photoshop clouds. If you've used Photoshop, you're familiar with that type of noise. And so if you have this scrolling texture and this mask that has this very like flame-like shape, then you can kind of combine those. You can multiply them together or use a different type of blending function. And then for this bottom right one, you can see that I've sort of added a bit of a distortion to that noise to make it kind of follow the shape of the flame as well, which makes it look way, way, way more realistic, and like it kind of follows the shape instead of it looking like completely detached from it, right? And all of this is done using code as well. So you might have a texture for the noise and the mask, but then the rest is just done real time on the GPU in your shaders. And then we have the bending when the rocket is turning left and right. And so what we're doing there is that we're effectively bending the coordinate system and warping it and distorting it in order to make the that rocket flame bend. So we're effectively just changing the coordinates of the space that we're sampling this in. And therefore we can kind of bend it this way. So this is, again, like applying lots of trigonometry to do this kind of warping. So see, use cases for trigonometry. Imagine that. Isn't that neat? And then lots more like esoteric and artistic things that you can do is that you can have textures that represent colors in ways that you might not be used to. So if you look at the left side, we have a flame that is just grayscale, right? So in this case, we just have a grayscale flame that it's bright in the middle and then it fades out toward the edges. And vertically, it is the time since you started accelerating or until you stop accelerating. So it's just a value from kind of 0 to 1. And so on the right, you can see that the color gradient that we use for the flame changes depending on how much it's grown. So if you're fully accelerating, it's at the top. And if you stop accelerating, it's at the bottom. And so I'm using this texture that I kind of hand painted just because I wanted to have specific colors over time. You can see that we have luminosity mapped to the x-axis, and then we have time on the y-axis. And therefore we get this like color shift across this flame because we're now sampling this like, well, an artist author texture to get this effect. And this really gives you a lot of flexibility. If I want to change the color gradient up here, I can just change the texture and everything works after that. I hope you're not super familiar with shaders, because then this might be just basic stuff.
Oh, this is great. It's blowing my mind. So
okay, good.
Don't worry. It's amazing.
And then finally, I had another effect where if you are moving against the flame, where you're kind of braking, then I wanted the flame to look a bit more squished. And so I added another coordinate scaling where I kind of squish the coordinates depending on if you're moving like really rapidly forward or if you're moving backwards and kind of accelerating against the direction you're moving in. And so that's just an example of the process of like building a shader like this. This is very much a VFX type of shader. And then, like I mentioned before, I sort of got into doing a lot of like math visualizations. So for example, here's a visualization of the dot product. So in this case, it's the dot product between two normalized vectors. And then you can see that you have this like scalar projection that gives you a value. And in terms of game development, you use the dot product quite a lot for just checking, how similar are two directions? Are you looking towards something or away from something? And a lot of like space transformation also involves the dot product. And I kind of, and one of the aspects of the type of work that I do is that everything is kind of real time. Like I do everything in Unity, the game engine. So all of these animations are done in Unity. And like for me, because I'm a game developer, it's very easy for me to experiment with this, and because it's the thing I've been using for like 10 years. And so I'm not going to learn anything new because I can do everything I want to do in Unity. And the kind of the fun side effect of that is that everything is real time. I generally don't have to render anything or wait for something to finish or build a model or anything like that. Usually everything is just real time. And so I started kind of experimenting with like kind of doing like an intersection of art and math, just kind of like, okay, what happens if I do the dot product between like all of these vectors instead of just one of them, and then kind of draw this little circle. I thought it was just kind of a fun exercise to see what would happen if I do that. And then of course, again, as soon as something is real time, it's very easy to iterate and it's very easy to experiment. So I started like, okay, what if I put the camera in a different perspective? Like, what if I kind of attach the camera to the arrow that's rotating around this this whole projective thing, and it looks kind of neat, right? I think it gives you like interesting perspectives to interpret these things from. And then finally I did a last one, which I really like, and it's kind of confusing because all of these are the same animation, just from a different camera angle. But this one is just kind of mesmerizing and confusing. And so I started doing a lot of math visualizations. So for example, here's one kind of showcasing the in-center of a triangle, and what that represents. And just kind of these short little looping animations. And again, all of these are made in Unity. I could make them using like processing, like P5.js or something, but I really like C# and I really like game engines. And so I'm just kind of pathologically attached to Unity forever and ever. And so part of making all of these animations is what kind of like inspired me to make a vector graphics library for Unity, because Unity doesn't actually have built-in tools for drawing, a pretty line with anti-aliasing at a given thickness. And so I started building all of these tools so that I could start visualizing math effectively. And so this one is, I forget how to pronounce it. It's like Gerstner waves or something, also known as like trochoidal waves. So this is kind of visualizing a type of wave of, I think it's an incompressible fluid. Yeah, so lots of things like this. So here's a visualization of Fortune's algorithm, which is a method of generating Voronoi diagrams. I don't know if you've seen Voronois before. I actually have no clue what you've already talked about during your courses. And so I'm just going to presume you know nothing, I guess.
I believe the audience is quite familiar with the Voronoi pattern. Yeah.
Okay, cool. But yeah, so this is one way of calculating it, kind of. It's not as continuous when you do it in an algorithm, but I think it's kind of an interesting way of visualizing it, because you kind of get more of an intuition about like how it works and why the parabolas work the way they do and so forth. And so, yeah, that's kind of lots of math visualizations. Like, for instance, this one is showing a geometric interpretation of the roots of a cubic function. So you can see that you just straight up have a, equilateral triangle, and the, I forget what it's called, the circle that touches all of the vertices. You can kind of just like visualize everything like this, and you have the in circle corresponds to the local maxima and local minima, and the center of the in circle is the inflection point of this graph. And again, just because I'm generally kind of allergic to numbers and equations, but as soon as you can make it visual, I become way more interested in it. And I just think it's really fascinating that you can have this like geometric interpretation of something that seems so math heavy, like finding the roots of the cubic equation, right? Circumscribed circle, that's the one. Thanks, chat. All right, and then yeah, so lots of math animations like this. Like this is the like how to create a circle from 3 points. Just kind of visualizing how that process works. You get the perpendicular bisectors, intersect them, and then you get the center of that circle. So that's kind of what I've been doing. I've been doing some like math art stuff that is kind of pointless, but just because I wanted to make this looping animations of a dodecahedron climbing a thing. So I've been doing a lot of like math art stuff like this that is just for fun, effectively. Or this little dodecahedron that's like stretching. It's a complete graph of a dodecahedron that's stretching because sometimes they have to stretch. Why not? A lot of people found this one very creepy. I think they wanted me to make like a horror game where you're fighting like mathematical primitives.
That's awesome. May I ask you, Freya, are the animations with the dodecahedron, are they actually mesh-based, or are you ray marching them?
These are all mesh-based.
Okay.
I've done some remarching, like I experiment a little bit with like sign distance fields because it's very fun to do that. And then eventually I kind of gave up on it because it doesn't have that much like application in game development. It's very fun to do like recreationally, but then in game development you don't use remarching that much. But I have experimented with it, and like I've used a lot of like 2D sign distance fields for throughout my vector graphics library. But in terms of 3D sign distance field, it's mostly been like recreationally, just been poking around at it. And then as of late, I've been very obsessed with splines and curves. I made a video quite a while ago on YouTube called The Beauty of Bezier Curves, where I talk about, well, Bezier curves, mostly the cubic Bezier curve. And since then, I've been kind of obsessing over splines for like about 1.5 years. I've been like digging deep into math papers with a lot of language that I don't understand because I'm not like formally educated. but yeah, so it's been really interesting exploring this. So for instance, this one, this is actually a cubic Bezier curve, and it's visualizing the curvature. So if it's a kind of a composite of a lot of osculating circles that are color coded based on which direction they're turning. So that's what this one is visualizing. And I'm sure you've talked about curvature combs at this point already, right?
I actually introduced them to your Splines video and the Bezier video. It's part of the lecture when I talk about functional representations of curves.
Okay, cool. Awesome.
Yeah.
Yeah, so lots of splines and visualizations, kind of like this one, which is visualizing the first cubic Bezier spline. Oh shit, wait.
It's frozen.
It's frozen. Hold on.
You are also a little choppy as well, your video.
Hold on. I'm confused because it says Zoom.
Is it just me, or is Freya a little choppy on your end?
I can't hear her anymore. She seems to have vanished.
Can you hear me now?
Oh,
yes, we can hear you now, and you're more fluid now. Yes.
That was really bizarre. It was like it said Zoom crashed, but I could still hear all of you. And so I don't know what that means. Maybe the screen share crashed on its own. Okay, I'll just try again.
Maybe that's what it crashed. Yeah.
Maybe
your animations are just too good for Zoom, you know?
I just got overwhelmed. Yeah.
Overwhelmed with beauty.
Okay, how about, is it working now? Is it fluid?
It is working. Yeah, it is back. Yes, it's great.
Okay.
Before we move on, there was a question here in the chat. Someone was asking, Kritika was asking, who's a teaching assistant, what platforms do you use for making these animations? And I ventured to say Unity plus shaders plus your shapes plugin. Is that correct?
Yep, it's all in Unity. I'm not sure I would recommend the platform for making animations because I do use so many custom tools at this point. But it is possible at the very least. But again, I've been working as a tech artist for a long time. And so making a vector graphics library and making all of the custom animation tooling, I won't say it was easy, but I had the knowledge to be able to do that, right?
If I may draw a comparison, Unity is so 3D based that doing simple vector graphics is actually not so straightforward. And one of the contributions from Freya is this library called Shapes, which uses shaders as a technology underneath to create vector graphics, very similar to things that you can do very easily in processing, for example.
Yeah.
Do you think is a fair comparison?
Yeah, absolutely. That's basically what, like, I wanted to make that style of animations that I could do in processing, or even in like HTML5 or just simple things in SVG. They're actually not that simple. It gets very complicated as soon as you want to do that, like in real time, and you want anti-aliasing on these, then it suddenly becomes a lot more complicated. And so I started just making all of these shaders because I needed them for my visualizations. And then I kind of turned it into like a library that other people could purchase and use in their own projects.
Well, I'm going to go back to that idea, the idea of like tools that you develop for yourself, but then developed farther into something that other people can use. I want to get back into that. Yep. But before, I want to relay a couple of questions from YouTube, and then Owen, I see your hand. So there's a question on YouTube. Saeed is asking whether if the flame on the shade that you were showing before, if it's just a single unscaled quad, or you were also doing transformations on the quad itself, on the triangles.
It's just a single unscaled quad, yes.
And then there's another question on the chat. Turkey Jerky is asking if you have ever done anything with 4D representation.
4D no, I have not. I've been doing a lot of stuff with quaternions as of late, but I don't want to call them 4D because I think that's a misleading way of interpreting quaternions. So no, I haven't done any 4D stuff.
Okay. Owen, you had your hand raised.
Yeah, it's not as specific of a question, but I was wondering, when you go out into new directions or start on a new project, what generally drives that? Is it there's a particular problem you're wanting to solve in a game, or is it more you run up with a particular type of math function or a new functionality in a program that really piques your interest, and then what you end up doing kind of springs from that instead?
I'm very much driven by whatever piques my interest. So it's the latter. I'm sort of in this lucky position where I'm kind of fully funded by selling my plugins on the asset store. That's like half of my income. And then the other half of my income is from my Patreon supporters. Because I do a lot of like live streaming and like stuff online generally and videos on YouTube. And so I'm in this lucky position of I can kind of do whatever I want as long as I can sort of monetize it and show it to people. And I think I just so happen to have like interest in a lot of these things. And so that's kind of just as of late what I've been pulled into. Like I mentioned, after the Bezier curve video, I started researching splines because I got interested in it and I wanted to learn more than just, the Bezier spline. There's a lot more splines out there. And so I just took this probably too long of a deep dive, like for more than a year, kind of like reading up on all of it. And so I have a video coming out soon. I think I'm going to release it on the 3rd of December. It's going to be a 1 hour and 10-minute long video full of animations similar to this, all about splines. And so that's what I'm pouring my time into as of late. But yeah, very much just driven by what I'm interested in. Yeah.
What a wonderful holiday season gift. I'm really looking forward to that.
Yeah. I hope it'll be interesting. Oh yeah, here's the one from the splash screen. There you go. You might recognize this one. I was experimenting with orientation on splines, which is a fascinating problem to solve. Because the orientation on 2D splines is very easy, but orientation on 3D splines gets really complicated depending on what type of orientation you want. And so that's what I've been focusing a lot on as of late. But yeah, we can just open it up for questions. I don't have anything else that I wanted to talk about, I think. Yeah.
Related to that, we have a question on the chat. Charlie McMacken is asking if the spline interest goes all the way, you think it's going to end up all the way into nerves geometry?
I wanted the video to be kind of a journey all the way from lerp to nerves. I wanted that to be the kind of the whole concept of the video. Unfortunately, I got hit by burnout a few months ago and I haven't been able to fully recover. And the video is already like 1 hour and 10 minutes long. And so I'm sticking to uniform splines for this video. So I'm basically going through Bezier splines, Hermite splines, or Hermites, I don't know how to pronounce French. The Hermite splines and Cardinal splines, Capmel ROM, and B splines. But I don't talk about the non-uniform rational B splines. I mentioned them at the very end of the video. So I guess I can, well, since everything is real time and I make it in Unity, I guess I could just show you. I can open my video editor and hopefully I don't run out of memory and crashing Zoom, but.
You made yourself a video editor in Unity?
Yes.
This is mind-blowing.
Well, I don't know if I want to call it a video editor because that kind of implies you're editing video files, but it's more like an animation tool. Okay, let's see if I can find. I have a single Unity project that contains all of my video stuff, which is not great, but it's fine. Okay, hopefully you can see this.
Yes.
Okay, so this is my video effectively in Unity, so I can jump to any point in this video. So again, because everything's real time, I can just go to any moment in the video, hit play, and kind of watch it from that point onwards. So yeah, in this case, I'm talking about like G1 continuity and showing a bit of an example of how that interacts between like circular arcs and straight lines. So that's that part of the video. And all of these animations are rendered in real time. And it's all done using my vector graphics library and animated in my custom timeline tool and whatnot. So yeah. So again, this is all 3D. I can like move around in the scene and like inspect the discontinuities here. Yeah, and so everything is kind of just like animating the camera around this 3D scene in order to like make all of these animations. But yeah, so in this video, I do this is about all of the things that I cover in my video. So I talk about these splines, and then again at the very end I mention NURBS. I just kind of offhandedly mention that, okay, non-uniform B-spline means that you can change the knot values, so you can have like non-uniform knot intervals. And then you can also make them rational. And what that means is that you assign a weight to every control point, and therefore you can kind of prioritize certain points over others. And that's NURBS. So I kind of talk about NURBS. I just have them at the very end of the video. Yeah, and then after this, it's basically just kind of showing another example where you have color space, and in color space, you quite often use linear splines in applications like Photoshop. So if you have a gradient, then, if you have a color gradient, then that's basically a spline in color space, so within the RGB cube. And then the input U value or T value to this function is going to be the luminosity of an image. And then using that image, you can pass it through the spline, and then the output is a color map, effectively a gradient map that you would use in things like Photoshop. And then if you modify the spline, you will obviously modify the output of this tool as well. That was just kind of the outro, mentioning a few like use cases for these things.
Oh my God, I'm so looking forward to this video. You're also gonna make me jobless. Like I don't have anything else to teach after this. This is just so good, you know?
You could just show them my video, and then and that's it.
I may just have to sit in class, just play your video, and just we all watch it together, you know?
I'm so sorry. Maybe I shouldn't release the video. I can just cancel. And
I would never accept anyone to being sorry because they're contributing something amazing to the community. I do not take that sorry.
We'll see how it goes. Yeah, I think I'm aiming to release it on December 3rd because I'm a perfectionist, and that kind of sucks because that means you're never done with anything. And so I just have to let go of this unfinished video, and just hopefully people will think it's okay. But yeah.
Okay. I see a couple questions on the chat, but before that, and related to NURBS. So could you tell us perhaps like where do you see how can I ask this question? So basically what I want to say is that in class, especially in the domain of 3D modeling that we're very used to here, we work a lot with NURBS because they give you, because they have an underlying functional representation from let's call it from an interaction point of view, as an UI for geometry modeling, if you will. They tend to be more fluid because they have all these properties, you know, the control points, the knots, the weights that allow you to smoothly change curvature, change form, and they tend to be like a very attractive interface to 3D modeling. Whereas, as opposed to NURBS as a paradigm for 3D modeling, there's always meshes, which is the idea of unstructured representation of form, no logic underneath, just like the discretization of reality in triangles, which is also arguably useful when you, for example, 3D print stuff, or when you're working in real-time computer graphics, especially video games. But there's always this like dichotomy of like, which projects are better NURBS-based, which projects are better mesh-based, from an interaction point of view, from a 3D modeling point of view, which one is better or more suitable? Where do you find yourself in this space? Have you found creative applications of meshes as a graph structure? How do you find NURBS modeling more intuitive?
I think there's in 3D modeling, especially in video games, there's generally kind of two different paths that you can take. So one of them is when you're making stuff like it's usually called hard surface modeling, and that's usually when you're designing like things with a hard surface, like I don't know, like this water bottle. Like maybe if I want to make this in a 3D application, then using NURBS for this is kind of nice because I can kind of just set up these like, you know, I set the radius and I set the bevel, and then I can kind of, you know, once I export it to a game engine, I can kind of configure like the level of detail on that later. Like I'm not like hard coding the level of detail into the like polygons. And so quite often when people do hard surface modeling, like robots or anything mechanical that doesn't have like a lot of organic forms, then quite often like using NURBS or subdiv surfaces is very useful, because you kind of retain all the information that you need in order to change the like level of tessellation. But then on the other hand, if you're making something that's more organic, like if you're making a character, then there's usually a lot more like organic forms. Like if you're modeling the face of someone, or if you're modeling just a body in general, or animals or monsters, in that case, people tend to have more of a sculpting approach. So I don't know if you've seen ZBrush or the sculpting tools in like Blender. Like quite often that's more like clay modeling, but digitally. So then you're kind of working with this like very dense like mesh data that you then afterwards like kind of convert to this more low resolution models that you would use in games, but you still use the like model that you've sculpted in order to generate textures that kind of give the model more detail than it actually has. Yeah.
Thank you. I see, Georgi, you have your hand raised.
Hi, yeah. So I think I was wondering, a lot of architects now are like thinking about like pivoting to game design industry, but I think all of them somehow lack of knowledge in like specific fields. I would be interested with what do you think, like what should architects learn if they want to go to the game industry?
If you want to go to the game industry, well,
Well,
I
like
guess it
game
depends
design.
on like what part of games, because games is a very, very, very broad like field. So like what part in that case?
I would say game design for like technical side of game design.
Okay, like game programming, like gameplay
Yeah.
coders, or I think in the games industry in general, people are very like, people generally don't really care about your academic credentials that much. It's usually about what can you show, and like where have you worked before. And usually like if you're passionate about it as well, that helps a lot. And so usually you would set up a portfolio where you like showcase some of your projects. You can make like tiny little mini games where you're like, okay, here's my character controller. I've designed it this way to make jumping feel good and snappy and responsive. And I designed the system for like platforming that allows you to like climb walls, and that makes it feel good for the player. And like kind of talk about your reasoning behind those things. But otherwise, it's mostly a matter of learning programming and getting good intuition for like what makes for good gameplay code. I think that's what any recruiter would be interested in at the very least.
On that note, Freya, could you perhaps like give us like a really, really quick rundown of the typical profiles of professions within the larger field of video game industry, and if you think architects could be a good match for some particular subspecializations within that field? I don't know, for example, like scene design, like 3D modeling,
yeah,
landscapes,
so
or is that a thing? I don't know.
I guess I actually don't entirely know about your field that much, so I'm not entirely sure what's like encapsulated by architect, but there's certainly people that design buildings and like work with like 3D structures like that. So usually it would either be like a level artist or an environment artist that would generally like make those types of decisions. I guess it depends on if you want to make the large scale structures and the layout, then that would be more of a level designer. If you are interested in the art side of it and making like everything look pretty and making the shapes of buildings look believable and whatnot, then I think a level artist or an environment artist would generally do that. So somewhere in that region, depending on like how big the company is, how many like roles they have, and how they split up the work. Generally, the smaller the company, the more hats you're going to have to wear. Yeah.
But those are like fairly known buckets of professions within video game design, if you will. Level design, level artist. Interesting. That sounds like possibly like a pretty good fit.
Yeah.
I'm gonna relay a couple of questions from the channel. So Rito is asking like if you have top 5 math or tech book recommendations that you loved.
No, I do not. The problem is that I haven't been learning anything that I do through books. It's always been like by literally just Googling for things. and kind of learning through trial and error. And so a lot of people ask me this question. I just feel bad because I just don't have an answer. I don't know. I'm sure there are good books out there. I just don't know them.
I would like to argue that your contributions in the form of videos are probably the new form of books. Like, I don't see why a book is any more
Maybe,
formal
yeah.
or more comprehensive way of what you're doing, really.
Yeah, whenever people ask like, oh, what do you recommend for learning math? And then I'm like, well,
My
here's my
videos.
YouTube channel.
Exactly.
Here's my math course.
Right. Okay. Ethicalicious is thanking you for your contributions and for your inspiration. And he
You're
or
welcome.
she over there, they are curious about your future plans for games or Unity plugins, or things you want to see created to make tech artists' life easier.
Wait, sorry, what was the question?
The question is like, what are your plans for, if I may summarize, like perhaps tools that you may offer in the future to make life tech artists easier?
Well, I mentioned before that I've been working on I guess I can show it. I've been working on a tool for splines in Unity because I guess there is a built-in spline tool in Unity, but it's not super good. And so I've been working on spline tools so that you can kind of make your own like extruding a mesh along a spline and whatnot, and like so you don't have to do that yourself. So I've been working on this plugin for a while now. And so that's one thing I've been wanting to do. Otherwise, I still update shapes every now and then. And then so this is kind of aiming to be a very advanced spline plugin where you have rotation interpolation as well, so that you can kind of define a more explicit shape like this. So that if you're making a roller coaster, generally you want to be able to like control very precisely how these should work and behave. And this fell out now. I'm sorry. I'm sorry, roller coaster.
Robert, I see you have a question.
Yeah, if someone has questions, fire away. I can just noodle around with my spline.
Yes. Thank you. Well, first of all, I just want to say thank you for coming to lecture. I don't think I've ever been this excited about math ever.
Awesome.
But I wanted to ask, because you talked about like what makes like what did you say? Like what makes, I guess, like a good UX for like a player? Like you were saying that basically it makes it like more like I forgot what you said. But like you said jumping on a wall would make the player happy, right? Or something like that. So I was wondering if you could talk more about kind of that, like, I guess the psychology behind that. Like what about jumping on the wall would make the user happy, or like good UX, for example? I'm just curious about that.
I guess I can do it. So I haven't made a lot of like 2D platformers, but you can see my screen still, right?
Yes.
So here's an example of something that might be a little bit counterintuitive that people have kind of worked out after a while is something that is important when you're making like a platformer. So let's say you have a character. This is the character. It's very beautiful. So let's say you have a platformer and you're running along this platform and you want to do just a normal jump to get to the next platform, right? So a classic thing when it comes to like gameplay programming and game design, when it comes to mechanics, is that if you just do the naive implementation of this, it would generally be something like, well, you're checking if the player is standing on the ground. Like if the character is grounded, then they can jump. But if they are in the air, then you're checking for the ground and there's no ground here and therefore they cannot jump. Like that's kind of the simple logic behind that, right? But then you might realize that a lot of players during playtesting, they run up to the edge and then they fall down and they just fall into the pit. And then they're kind of like, what? Why did this not work? Like I jumped, I actually pressed, but nothing happened. And usually what happens is that what you're doing when you're checking if you're on the ground, like this checking, you might sometimes want to add more leniency to that. So in like most platformer games that feel good to play, they actually allow you to jump a little bit outside. So even if you like run off the edge of a platform, if you're kind of close to a platform, they generally let you jump anyway, because they have a bit of a like delay that lets you still do that input for jumping. And so then you can make the jump, even though you're technically not grounded at this location. And if this topic goes extremely deep, if you want to like get into like platformer gameplay programming, but this is something that you kind of realize after play testing, like having players test, see where they fail, where do they get frustrated, why does it not work the way that I think it's going to work. And so this is just one example of the things that you might realize. So a lot of these like little marginal edge cases, in this case, I guess a literal edge case, that you have to like add a little bit of like leeway in order to make the gameplay feel good. Like there's a lot of things like that in game development. I don't know if that answered your question, but yeah.
Oh, it totally did. Thank you. Yeah, I was just curious
it's called
about
coyote
like what
time if you want the
Got it.
lingo.
Thank you.
I actually see people in the chat pointing out that this is called coyote time. I had no idea about that. Beautiful. Turkey Jerky is relating to the idea of, is asking how do you stay focused on a given topic? Like Turkey expresses how their curiosity sends them off on tangents way too frequently. So how do you stay focused on like the one thing, the one project, and bring it to fruition?
I wish I knew the answer to this, because personally, I am, like I mentioned, I'm like kind of independent now, where I'm fully funded by my own community, and selling things on the asset store. And so I've had this problem all my life. I just happen to be interested in things that I can monetize. So I'm surviving because of that. But otherwise, I'm kind of just following my whims, like whatever I'm interested in, I pursue that to my fullest extent. And I try to go all the way to the end on everything I'm interested in. And so I don't really know the answer to like, how do you stay focused on something you're not interested in? I wish I could do that. And if you know the answer, let me know in the comments, because I have no idea.
May I ask a question of my own? Speaking of tools, a lot of what we talk about in this class is the idea that by learning computational design, by learning tools such as, for example, how to write C#, et cetera, which is mostly what we learn in this class, actually. How with that, we're able to supersede what standard tools give us, and then we can start customizing them and even creating tools for other people to use.
Yeah.
So in your case, for example, you started with shapes as a tool that you needed for your own work. And then that evolved at some point and you decided, well, maybe I can package this or I can reshape this on something that is helpful for other people and that I can even monetize. How do you tell us a bit about like how you change those hats, how you go from something that you design for yourself and how you change the hat of like, how do I rethink this with other people in mind? What are your thoughts processes behind that?
Generally, that's all about like expanding something to like a wider audience. Like you have to sort of cover all use cases. Quite often in game development, you kind of specialize everything to your specific game. But when you're making a tool, all of a sudden you have to like, okay, well, someone might want to use the splines not just to make a road, but maybe they want to make like, I don't know, hanging cables. And then maybe it's good to support like the catenary curves, or I don't know. Like generally, it's a matter of just like covering all the use cases that people are going to want to use it for, which is it's a very arduous process to like add all of those features, because you're basically kind of feature creeping. Like you're just like, you have to add everything. And so there, it's mostly about like figuring out where to draw the line. Like where do you draw the line to say this is not something that my tool is going to do? Yeah, that's kind of the tricky part there, because like in my case, I'm just one person, and I'm also going to have to deal with all the support requests that people send my way, where like more than half of them are just questions about Unity. Like it's just like, oh yeah, this is a bug in Unity, or like this is how you do this Unity thing, rather than like the thing about my plugin. But yeah.
Do you think there's something about that changing hats, or that like impersonating yourself into other people's minds, that also affects the way you think your educational outreach? So how you understand splines, you know how to work with them, but then you have to create a video where you explain this to other people. And and then you have to like kind of like situate yourself into other people's minds.
Yeah.
Is there any correlation here?
I mean, it's something I do all the time. Like it's absolutely like everything from game development and game design. I've just like pulled in that for all of my educational stuff. And yeah, so it's just about like if you're making something educational, like the way you talk about it, the direction you approach it from, all of that is just about thinking like, what's the user experience going to be like? What do I want all of you to learn? And then I kind of try to design that to be as interesting and visually like appealing as possible. And so, yeah.
Beautiful. Well, we're approaching our end of the call. I want to open it up to any last minute questions from the audience.
Oh yeah, I had planned to like show a little bit of shader coding.
Let's do that. Yes.
You can like find questions while I do that. I just wanted to show an example of like how like what shader coding can look like. And so in this case, this is in Unity. And this is just a what's called a quad. It's just two triangles. And so what you're seeing here is we're kind of visualizing the coordinates of this geometry. It's black in the bottom left, and then it goes towards red along the x-axis, and then it goes towards green on the y-axis. And so what we're looking at is we're interpreting the coordinates as a color. And in shader programming, colors and vectors and coordinates are all interchangeable. And so whenever you're making something visual like this, you quite often like literally debug it by outputting whatever you're making as a color. And so for example, we can just edit this if we want to. So if we take our coordinates here, so maybe we can make a variable for that. You can still see my window, right? I think
yes.
Yeah. So in this case, we're using something that's called UV coordinates, and we're outputting that. But then what if we multiply that by 2, for instance? Like if we multiply these coordinates by 2, then you can see that we've kind of shrunk this. So now it's like down in the bottom left corner, and then we have values outside of 0 to 1 as we go further away. And then we can do things like maybe we can repeat these coordinates. So we can use a function called frac, which is basically x minus floor of x. And so now we're repeating this pattern, and like all of this is real time. So we can keep like just adding things to this. Like for instance, we can add the current time in seconds. And now we have this moving pattern. And if we can use these coordinates to like map textures to it. So if you're making like a waterfall in a video game, then maybe you want a panning texture that's like scrolling downwards. So, and then you can do stuff like maybe you want to get the length of this coordinate. So just getting the length of the vector that represents this coordinate. So we're gonna rename this. So I guess we can do this. And so now we have a radial mask. Now we can see that we have a gradient from 0 in the corner, and then it goes higher and higher the further away we go. So now this is kind of visualizing the distance to the origin, right? And then maybe we can offset the origin, so we can move the origin over here. And then what if we multiply this by 3? Then we got this circle right here. And then maybe we can invert this as well. So 1 minus, so we're just flipping this. So now we have something that kind of looks like a sprite, right? In a video game, it might be like a glow from a light source or something. And then we can experiment with this further. Like what if we take this one and divide it by the screen space partial derivative of this function? So if we do that, let's see, this should be a float. And then, so now we've created a disk, like just a simple disk even with anti-aliasing, because we're doing the screen space partial derivative. So now all of a sudden we've basically made a vector graphics disk using only shader code. And so a lot of the stuff that I do in my vector math library is this, where I just create various shapes using math defined in code. Well, of course, in shapes, things are a little bit more complicated. They get way more complex than this. So in shapes, for instance, I have this like regular polygon component. We're just going to let this infinite roller coaster go in the background. So in here, for instance, maybe I want to make a pentagon that's a little bit rounded around the corner, and maybe I want it to be have a specific thickness. And so maybe I can do that. And again, this is all just in shader code. And this is just 2 triangles for this entire shape. And so I can make it dashed as well. I can offset the dashes over time. If I just change this value, I can make like rounded dashes. And so this is what I've been focusing on a lot. It takes a long time to like define all this mathematically. But yeah, so that's kind of the process of like doing this using shaders. Sorry, I'm taking up a lot of time just explaining this. But,
Oh, no, we're still in time. If I may introduce like an ad on this call, if you're interested in shaders and image processing and understanding color as vectors, etc., that's a lot of what we talk in the next class after this one in artifacts as media. We teach a 3-course sequence here at the GSD, and for which Into the Computation is the first one, and then it's continued by other 2 more advanced courses.
This roller coaster is not physically accurate. Just a heads up. I haven't done the physics correctly, so that's why it's going just slowly accelerating over time.
Beautiful.
All
Well,
right, were there any more questions? I have not been reading chat. I feel like I probably missed a lot.
It's okay. Perhaps you can address it if you want later. But I think with this, I think this was great. I would think we would want to keep it here. So thank you very much, Freya. Thank you for being with us today. It was amazing. Can you please join me in thanking Freya right now?
Oh yeah, no, thank you so much for inviting me. Oh yeah, I guess I'm gonna be live for a little bit longer on my stream. So if you have questions and you wanna chat some more, then I'm gonna be live on twitch.tv/ACEGIKMO. It's every second letter from A to O. That's my online nickname. So you're welcome to join my stream on Twitch. I'm gonna be streaming for a little bit longer, maybe at most an hour, not much more than that, but yeah.
All right. It was a big pleasure. Thank you, Freya.
Thank you so much for having me.
Bye-bye.
Bye. All right.
I'm going to stop recording.
You know, I
I
thought I wouldn't be able to.
Hold, give me 1 second, please.
Yeah, okay.
Yes. Finishing the stream.